This is everything you need to know for Algebra 1, Part 1. So we're talking about the real number system today, and really it's just a way to categorize different sets of numbers. So in algebra, everything that we talk about are real numbers. Now, there are imaginary numbers, but you won't learn that until Algebra 2. So let's start with the smallest set first. So we have natural numbers. Natural numbers are also called counting numbers because they're the numbers that you think of whenever you count. So 1, 2, 3, 4, 5, and so on. Okay, so I'm just going to put 1, 2, 3, dot, dot, dot. Okay, so notice we don't have any decimals or anything like that. It's just whole numbers counting starting at 1. All right, the next category is whole numbers, and whole numbers include all the natural or counting numbers, plus you also include 0. So for that, I'm going to put 0, 1, 2, 3, dot, dot, dot. So the only difference is that you include all the natural numbers and you include 0 in that category. The next category is integers, and so integers includes all your whole numbers plus their negative versions of those numbers. So you're going to have 0, 1, 2, 3. You're also going to have -1, -2, -3, and so on. Okay, so for integers, I'm going to put -3, -2, -1, and you're also going to be including 0, 1, 2, 3, all the way to infinity. Okay. All right, so that gets us to rational numbers. And so rational numbers includes all of these. So all the integers, whole numbers, natural numbers, and it includes anything that can be written as a fraction. Okay, so that could also include 2/3 or 7/8. Okay, so numbers like that have repeating or terminating decimals, which means they can be written as a fraction. So if that's rational, then what's irrational? Well, irrational numbers are numbers that cannot be written as a fraction, which means that they don't have repeating decimals or terminating decimals. It's just decimals that keep on going forever. So think of like the square root of 3. Okay, 3 is not a perfect square, so we can't really take the square root of it without just getting a lot of decimals that keep on going and going. So the square root of 3 is equal to 1.73205 dot dot dot, and it just keeps going with random decimals forever. Another example of an irrational number would be pi, because pi also has decimals that keep on going forever and ever and don't repeat or terminate. And like I said at the beginning, all of these sets of numbers that we're talking about are also real numbers. So if you like this video, go ahead and follow this account, like this video, and leave a comment. That way these videos will show up in your For You page later on, and we'll see you next time.